Imagine gazing up at the night sky and unlocking the deepest secrets of the universe. What if I told you that we've already done that and we're just getting started? Space telescopes like the iconic Hubble and the groundbreaking James Webb are our eyes in the cosmos, revealing stunning images and discoveries we never thought possible. From unraveling the mysteries of distant galaxies to searching for signs of life on faraway planets, these cosmic instruments are pushing the boundaries of science and redefining what we know about our place in the vast, infinite universe. Ready to dive into the world of space telescopes? Let's embark on this cosmic journey together. The world of space telescopes. From Hubble to James Webb. In the vast expanse of space, where billions of stars twinkle and galaxies swirl in the depths of time, human curiosity has always reached for the stars. For centuries, we've wondered about the universe's origins, its vastness, and our place within it. Our first steps into answering these questions came with the invention of the telescope, an instrument that would change the way we view the world. However, when the night sky above us was no longer clear enough to reveal its mysteries, humanity made an unprecedented leap, taking telescopes into space. In this journey, two giants stand tall, the Hubble Space Telescope and the James Webb Space Telescope. These two instruments have reshaped our understanding of the universe and, along the way, have provided breathtaking images and mind-blowing discoveries. But how did we get here? What makes these telescopes so powerful? And what does the future hold for space exploration? The birth of space telescopes. The story of space telescopes began long before Hubble and Webb. In the early 20th century, astronomers could only view distant stars and galaxies through telescopes positioned on Earth. However, Earth's atmosphere posed a major challenge. The atmosphere scatters and distorts light, which means that no matter how powerful the telescope, the images always lacked sharpness. To solve this problem, scientists realized that the solution was to take telescopes out of Earth's atmosphere, into the vacuum of space itself. This idea of a space telescope was first imagined in the 1940s, but it was not until the 1970s that the idea began to take shape. Scientists and engineers at NASA began to push forward with plans to build the first ever space-based observatory. Their vision would culminate in the Hubble Space Telescope, which launched in 1990, marking the dawn of a new era of space exploration. Hubble Space Telescope, the pioneer. When the Hubble Space Telescope was launched aboard the Space Shuttle Discovery on April 24, 1990, the scientific community had high expectations. However, the initial excitement was marred by a major flaw. The telescope's mirror had been ground incorrectly, causing blurry images. This flaw threatened to derail the entire mission, but instead of giving up, NASA sent a repair crew to fix the telescope during the 1993 Space Shuttle mission. This mission was a turning point for Hubble. Once the mirror was fixed, Hubble's potential was fully realized. Hubble was positioned in low Earth orbit, 547 kilometers above the Earth's surface. Free from the interference of Earth's atmosphere, it could peer deeper into the universe than ever before, offering us sharp, clear images. It could observe objects in a variety of wavelengths, from ultraviolet to infrared, and deliver data about distant stars, nebulae, and galaxies. Perhaps one of Hubble's most famous achievements came in 1995 when it captured a deep field image that would change the course of astronomy. The image, known as the Hubble Deep Field, was taken by pointing the telescope at a seemingly empty patch of sky. After 10 days of exposure, the image revealed over 3,000 galaxies, some of them more than 13 billion light-years away. This single photograph was proof that the universe was far more expansive than anyone had ever imagined. But Hubble did more than just capture breathtaking images. It also helped scientists answer some of the most fundamental questions about the universe. In 1998, Hubble's data played a crucial role in the discovery of dark energy, an unknown force accelerating the expansion of the universe. The telescope also helped refine measurements of the universe's age and provided insights into the formation of stars and galaxies. Over its 30-plus years of service, Hubble's discoveries have reshaped our understanding of space. It provided stunning images of the birth of stars in regions like the Eagle Nebula and the Pillars of Creation, and it observed some of the most violent phenomena in the universe, like supernovae and black holes. The next step, the James Webb Space Telescope. As incredible as Hubble was, it was clear that its successor would need to be even more advanced. While Hubble observed in visible and ultraviolet light, it was limited in its ability to detect the faintest signals from the very early universe. For that, scientists needed a telescope that could observe in the infrared spectrum. This led to the development of the James Webb Space Telescope, JWST, a telescope that would go beyond Hubble's capabilities and peer even deeper into the cosmos. The James Webb Space Telescope was conceived in the 1990s, with the goal of observing the universe in infrared light. Infrared light has longer wavelengths than visible light, allowing it to pass through cosmic dust that often obscures objects in space. This makes it ideal for studying distant objects, including the earliest galaxies that formed after the Big Bang. Webb's design is vastly different from Hubble's. Whereas Hubble was compact and could be serviced by astronauts, Webb was built to operate autonomously. One of the most remarkable features of Webb is its enormous 6.5-meter primary mirror, almost 3 times the size of Hubble's. This mirror is made up of 18 hexagonal segments that were carefully constructed to fit together like pieces of a giant puzzle. This massive mirror allows Webb to collect more light, enabling it to detect faint objects billions of light years away. Another key feature of Webb is its ability to observe the universe in infrared light. Webb's 4 main scientific instruments, the near-infrared camera, NIRCam, the mid-infrared instrument, MIRI, the near-infrared spectrograph, NIRSpec, and the fine guidance sensor/near-infrared imager and slitless spectrograph, FGS/NIRIS, allow it to capture detailed images and spectra from distant stars, galaxies, and even exoplanets. Webb's location is also quite unique. While Hubble orbits Earth, Webb will orbit the Sun, positioned at a location known as the second Lagrange point, or L2, about 1.5 million kilometers away from Earth. This spot is far enough from Earth's interference, but allows Webb to stay in a stable orbit and constantly point its instruments away from the Sun, Earth, and Moon. Webb's capabilities and discoveries. The launch of Webb on December 25, 2021, was one of the most anticipated events in the history of space exploration. After months of travel, it successfully reached its destination at L2 and began the process of unfolding its solar panels and mirrors. On July 12, 2022, Webb's first full-color images were released, marking the beginning of a new era in astronomy. One of the first images Webb captured was a stunning view of a galaxy cluster known as SMACS 0723. This image revealed thousands of galaxies in an area of space previously unseen, with the galaxies stretching back over 13 billion years. Webb's ability to capture such an image is due to its incredible sensitivity to infrared light, which allowed it to observe distant galaxies and stars. Webb is also able to peer into the atmospheres of exoplanets. One of its goals is to study the chemical composition of these distant worlds, searching for signs of habitability or even life. Webb's instruments have already begun studying the atmosphere of exoplanets, detecting elements like carbon dioxide, methane, and water vapor. Some of these elements are key indicators of life as we know it, and Webb's ability to study these distant worlds brings us closer than ever to answering the age-old question: are we alone in the universe? Webb's ability to capture infrared light also means that it can study the early universe in unprecedented detail. Webb's infrared vision allows it to observe the formation of the first galaxies and stars, shedding light on the universe's early days. With Webb, we can now peer back in time to just a few hundred million years after the Big Bang, witnessing the birth of the first galaxies and the growth of the cosmos. Hubble and Webb, working together. While the two telescopes have different strengths, they complement each other perfectly. Hubble, with its sharp visible light imaging, continues to provide incredible views of the universe, from the detailed structure of distant nebulae to the birth of stars in nearby galaxies. Webb, on the other hand, is unveiling the earliest stages of the universe, studying objects that are invisible to Hubble's eyes. Together, Hubble and Webb offer a comprehensive view of the universe. While Webb studies distant galaxies and the birth of stars, Hubble is continuing to capture stunning images of the cosmos in visible light. The two telescopes work hand in hand, providing an unparalleled perspective on the universe's past, present, and future. The future of space telescopes. While Hubble and Webb are the giants of today, the future of space telescopes is already being planned. Missions like the Nancy Grace Roman Space Telescope, set to launch in the mid-2020s, will complement the work of Webb and Hubble by studying dark energy and exoplanets in even greater detail. Additionally, new telescopes are being designed to observe the universe in other wavelengths of light, from radio waves to X-rays, ensuring that the next generation of space telescopes will continue to push the boundaries of what we know about the cosmos. The human spirit of exploration. As we journey through the cosmos with telescopes like Hubble and Webb, we are reminded that this quest for understanding is more than just a scientific endeavor. It's a reflection of the very essence of humanity, our boundless curiosity, our desire to explore the unknown, and our constant search for meaning in a seemingly infinite universe. Space exploration, while often depicted as a pursuit of science, is also a deeply human story. Behind every telescope, every image, every discovery are the countless minds of engineers, scientists, astronomers, and visionaries working together to unlock the mysteries of the universe. These collaborations across countries and disciplines bring the best of human ingenuity to the forefront. At its core, the creation and operation of space telescopes are a testament to what we can achieve when we push the boundaries of our knowledge and resources. It's a collective endeavor that has spanned decades of planning, testing, and building. The Hubble Space Telescope, for example, was not only a technological marvel, but also a testament to the perseverance of those who worked tirelessly to fix its flawed mirror. That same spirit of determination continues with Webb. Despite the challenges that came with building such a complex instrument and the hurdles of its long journey to L2, its discoveries have been nothing short of revolutionary. Space telescopes represent the hope that, despite the obstacles we face on Earth, the pursuit of knowledge and understanding remains a noble cause, one that transcends borders, cultures, and time. They remind us that the universe, vast and mysterious as it is, belongs to all of us. Whether you are a scientist studying the stars or simply someone gazing up at the night sky, the discoveries made by these incredible machines are something we all share: the legacy of exploration. As we look toward the future, it's important to reflect on the legacy of the space telescopes that have come before and those still to come. Hubble's images have shaped our imagination and sparked curiosity for generations. Its photographs, like the Hubble Deep Field, which showed us a snapshot of the universe as it existed billions of years ago, have etched themselves into the collective consciousness of humanity. That image, in particular, highlighted something truly profound. The universe is far older and more complex than we ever dreamed. Webb, with its launch in 2021, is already creating its own legacy. It's not just about capturing incredible images of the universe. It's about understanding how galaxies formed in the early universe, how stars were born, and how life might exist on faraway exoplanets. With its advanced technology, Webb has the potential to answer some of the most profound questions in science, pushing us closer to understanding the origins of life itself. But the story of space exploration is far from over. As new telescopes are developed, new questions will arise, and new mysteries will unfold. Each new telescope brings us closer to answering the fundamental questions about our existence. How did the universe begin? What is dark matter and dark energy? Are we alone in the cosmos? One day, space telescopes may provide the answers to these questions, revealing more about the nature of reality than we ever imagined. But no matter what the future holds, the legacy of Hubble and Webb will serve as a reminder of the incredible things we can achieve when we look beyond our world and toward the stars. The role of space telescopes in everyday life. It's easy to think that space telescopes and the research they conduct only have implications for scientists or astronomers. But in truth, these technologies have had a much wider impact on our daily lives, even in ways we may not realize. For one, many of the technologies developed for space telescopes have trickled down into other industries. The imaging technology developed for the Hubble Space Telescope, for example, has found applications in medical imaging, including advancements in mammography and other diagnostic tools. Webb's infrared sensors could pave the way for better climate monitoring on Earth by detecting subtle changes in temperature and atmosphere, helping scientists track environmental shifts. Innovations originally designed for space exploration have proven to be invaluable in addressing some of Earth's most pressing issues. Moreover, the sheer act of observing the universe with space telescopes reminds us of the interconnectedness of everything. It brings people together, whether in awe or wonder, and encourages us to take better care of our planet. When we look at Earth from space, as Hubble has done on several occasions, we are reminded of how fragile our planet is. Seeing our home from the perspective of space encourages us to protect it, to cherish the life we have, and to consider our place in the vastness of the universe. The human future in space. While Hubble and Webb are primarily focused on studying distant stars and galaxies, the advances in space telescopes also point toward humanity's long-term future in space. As we continue to explore and understand the universe, the dream of venturing further into space becomes more tangible. Space telescopes like Webb are not just about observing the universe, but also about preparing us for the future of space travel and colonization. As we learn more about distant planets and exoplanets, we inch closer to discovering habitable worlds. The search for life on exoplanets, a key goal of Webb's mission, is deeply connected to the future of human exploration. If life exists elsewhere in the universe, it could open up new possibilities for human expansion beyond Earth. In a world facing climate change and other challenges, the idea that humanity might one day call another planet home has inspired many to pursue careers in space exploration, engineering, and astrobiology. Webb's findings may also lay the groundwork for future missions beyond the solar system. While current technology doesn't allow us to travel to the stars, the discoveries made by Webb will help us understand which distant worlds might be the best candidates for future exploration. Perhaps one day, we'll send human missions to these faraway planets, all thanks to the work that's being done now by space telescopes. The unseen frontiers of space. As we continue to make strides in our exploration of space, there are still vast, uncharted regions of the cosmos awaiting discovery. The Hubble and Webb telescopes, incredible as they are, represent just the tip of the iceberg in our quest to understand the universe. While they've provided us with breathtaking views of distant stars, galaxies, and nebulae, much of the universe remains hidden from our eyes, waiting for the next leap in technology to reveal its secrets. One of the most exciting areas of future exploration lies in the realm of dark matter and dark energy, two of the universe's most elusive and mysterious components. For decades, scientists have known that most of the universe is made up of these invisible forces, yet we still don't fully understand what they are or how they work. Dark matter, which makes up about 27% of the universe, doesn't emit or interact with electromagnetic radiation, like light, making it nearly impossible to observe directly. Dark energy, even more mysterious, accounts for about 68% of the universe and is responsible for the accelerated expansion of the cosmos. Both Hubble and Webb will continue to provide valuable data about these mysterious substances, but the true breakthroughs in understanding dark matter and dark energy may come from future missions designed specifically to probe these hidden frontiers. Instruments on upcoming space telescopes could allow us to track how dark matter interacts with galaxies, or perhaps even uncover new particles that could help us better understand the nature of the universe itself. As the universe remains shrouded in these enigmatic forces, the next generation of space telescopes will need to push the boundaries of our understanding in ways we can't yet predict. However, the promise of discovering the unknown, of revealing what's beyond the observable universe, keeps scientists pushing forward, one breakthrough at a time. The role of space telescopes in collaboration. While we often think of space exploration as an individual country or agency endeavor, the reality is that international collaboration has been crucial to the success of both Hubble and Webb. Space exploration is a global effort, with scientists, engineers, and astronauts from every corner of the world working together toward the same goals. The Hubble Space Telescope, for instance, was a joint project between NASA and the European Space Agency, ESA, with contributions from the Canadian Space Agency, CSA. This partnership allowed for the pooling of resources, expertise, and technology to create a telescope that would ultimately revolutionize our understanding of the universe. Similarly, the James Webb Space Telescope is a joint project between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. These collaborations ensure that space exploration is a collective human effort, one that draws on the strengths of many nations and cultures. The shared goals and knowledge among countries involved in space exploration create a sense of unity that transcends national borders. This unity is essential as we move further into the unknown. As our scientific instruments become more advanced, as our reach extends farther into the universe, collaboration will be more important than ever. The challenges of space exploration, building powerful telescopes, launching them into orbit, and analyzing the vast amounts of data they produce are simply too great for any one country to tackle alone. By working together, we maximize the potential for discovery and ensure that the benefits of these explorations are shared by everyone on Earth. Whether it's through the creation of new technologies, the unraveling of universal mysteries, or simply inspiring future generations to look to the stars, space telescopes play an essential role in our collective journey. Space telescopes and humanity's legacy. The impact of space telescopes goes beyond science. They touch the very core of human imagination. When we look up at the stars, we don't just see distant lights in the sky. We see our own potential. The ability to gaze into the depths of the cosmos, to understand the forces that govern the universe, is a powerful reminder that we are part of something much larger than ourselves. For centuries, the stars have been a source of wonder, a symbol of the unknown and the unknowable. Space telescopes have brought us closer to understanding the true nature of the universe, helping us answer questions that have been asked since the dawn of human civilization. What is the universe made of? How did it begin? Are we alone? The answers to these questions will shape humanity's legacy. As we push the boundaries of what's possible with technology, we continue to expand our horizons, not just in terms of the physical universe, but also in terms of our understanding of life, consciousness, and our place in the cosmos. The discoveries made by Hubble and Webb are not just milestones in science. They are steps toward unraveling the mysteries of existence itself. Space telescopes allow us to glimpse the infinite, yet they also remind us of our responsibility to protect our own planet. The more we learn about the universe, the more we realize how fragile our existence is, how rare and precious life on Earth may be. With the knowledge gained from space telescopes, we are better equipped to care for our planet and to safeguard its future. As we continue to study the universe, we are reminded that our legacy as a species will be measured not just by the advances we make in technology, but by the wisdom we gain in our pursuit of knowledge. Whether we explore the farthest reaches of space or look inward to understand the workings of our own world, the journey will define us. A never-ending journey. The story of space telescopes is not a static one. It's a dynamic, unfolding narrative. What started with the Hubble Space Telescope, a groundbreaking instrument that gave us our first clear views of the cosmos, has now evolved into a new chapter with the launch of the James Webb Space Telescope. As Webb continues to send back data from its perch at L2, it is already beginning to answer questions that have lingered for decades and raising new questions that will likely fuel further exploration for generations to come. What's next in the world of space telescopes? The future is filled with exciting possibilities. With technological advancements, we may soon see telescopes capable of observing the very first moments of the universe or detecting alien life on exoplanets. New methods of data analysis, machine learning, and artificial intelligence will help scientists sift through the immense amount of data these telescopes generate, enabling faster and more accurate discoveries. In the coming decades, we may see even more ambitious missions. Telescopes capable of observing phenomena that are currently beyond our comprehension, such as gravitational waves, black holes, or even the elusive signatures of life elsewhere in the galaxy. With every new discovery, humanity's understanding of the cosmos will expand, and with it, our sense of wonder. The exploration of space is a never-ending journey, one that will continue to evolve with each new telescope, mission, and discovery. As we continue to peer into the depths of space, we not only learn more about the universe, but also about ourselves. In the grand expanse of time and space, we are small, but our capacity for exploration and discovery is limitless. Closing thoughts. A glimpse into the infinite. As we stand at the crossroads of the past, present, and future of space exploration, we realize that the universe is a story still being written. Hubble and Webb have given us glimpses into the infinite, showing us the beauty, complexity, and mystery of the cosmos. They've provided a lens through which we can peer back in time, examine the building blocks of the universe, and search for answers to questions we've only just begun to ask. But the story is far from finished. There are still millions of galaxies to explore, billions of stars to study, and countless mysteries to unravel. With each discovery, we move closer to understanding the fundamental nature of the universe and our place within it. Space telescopes are our windows to the stars, and the journey of exploration will continue, inspiring future generations to dream, to discover, and to reach for the stars. As humanity looks to the future, we remain ever curious, ever eager to explore the vast unknown. Space telescopes will continue to guide our way, shining a light on the darkness and revealing the wonders of the universe that have always been there, waiting to be seen. And with that, the journey through the cosmos continues. Each new telescope, each new discovery, brings us one step closer to understanding the infinite. The story of space telescopes is a story of human ingenuity, of striving for knowledge, and of the unyielding curiosity that defines us as a species. The universe is vast, and the possibilities are endless. And with every new telescope, we look deeper, farther, and with even greater wonder than before. This concludes the extended story of space telescopes, Hubble and Webb, capturing the essence of their importance while imagining the future of space exploration. Let me know if you need any changes or additions. The interconnection of space telescopes and earthly technologies. While space telescopes like Hubble and Webb are designed to peer into the deepest reaches of space, their discoveries and the technologies developed for them have profound effects here on Earth as well. The very nature of space exploration demands innovation in engineering, computing, and communication technologies. What we learn from building and operating these telescopes doesn't just expand our understanding of the cosmos. It also advances the technology we use in everyday life. One of the most notable examples of technology transfer from space exploration is the development of better imaging systems. The precision required for capturing the vast and intricate details of distant galaxies has resulted in improvements to medical imaging techniques such as MRI scans and X-ray systems. The algorithms used to enhance the sharpness of space telescope images have found applications in a variety of industries, from improving the quality of digital photos to enabling high-definition video streaming. Similarly, The software systems created for space telescopes, particularly in the areas of data analysis and management, are increasingly applied to solve complex problems in other fields. For example, the techniques used to analyze the massive amounts of data generated by Webb and Hubble have been adapted for use in climate modeling, financial forecasting, and artificial intelligence applications. This cross-pollination of ideas not only accelerates the pace of scientific discovery, but also creates a feedback loop of innovation that benefits all of humanity. Furthermore, space exploration has led to advancements in communication technologies. The methods used to transmit data from space telescopes back to Earth over vast distances with minimal delay have paved the way for advancements in satellite communications, broadband internet, and even the development of 5G technology. As we continue to push the limits of space exploration, the technologies that emerge will help connect people around the world, making our planet smaller and more interconnected than ever before. The philosophical implications of space telescopes. Space telescopes also raise profound philosophical questions about our place in the universe. As they unveil the intricate details of distant stars, planets, and galaxies, they challenge our perception of humanity's significance in the grand expanse of space. How do we reconcile the vastness of the cosmos with the idea of our own importance? For centuries, humans have believed that Earth is the center of everything. But the discoveries made by space telescopes have shown us just how small and fragile our planet is in the context of the entire universe. The images sent back by Hubble and Webb of billions of stars, galaxies, and nebulae remind us that we are but a tiny speck in a cosmic sea of infinite wonders. Yet, this knowledge doesn't diminish our significance. In fact, it enhances it. Understanding the immense scale of the universe encourages us to value life and our planet more deeply. It reminds us of how precious and rare our existence is, and how important it is to preserve the delicate balance that allows life to thrive on Earth. In a way, space telescopes give us a broader perspective, one that transcends national borders, cultural divides, and personal differences. When we look at the images from these telescopes, we see the universe as it truly is: vast, interconnected, and filled with potential. It is a humbling reminder that we are part of something much larger than ourselves, and that our actions here on Earth have consequences for the future of humanity and the planet as a whole. The role of space telescopes in future space colonization. As we continue to explore and understand the universe through space telescopes, the next logical step for humanity might be to extend our reach beyond Earth, to other planets and even other star systems. Space telescopes will play a vital role in this process, not only by helping us identify potentially habitable planets, but also by providing data that will guide our efforts in space colonization. The search for Earth-like exoplanets, which Webb is already contributing to, is one of the most exciting areas of research today. Astronomers are eager to identify planets with conditions similar to those of Earth, planets that might have liquid water, an atmosphere, and the right chemical elements to support life. These exoplanets could serve as potential destinations for future human missions, perhaps even colonies, as we face the challenges of climate change and the long-term sustainability of life on Earth. In addition to identifying habitable planets, space telescopes will help us understand the potential hazards of space travel and colonization. Webb and future telescopes will study the radiation environments of distant stars, the composition of planetary atmospheres, and the surface conditions of exoplanets, all of which are critical factors for planning long-term space missions. They will help us determine whether a planet is truly capable of supporting life, or if it's just a barren rock, inhospitable to human beings. Space telescopes will also assist in locating resources in space that could be used for future colonization efforts. Asteroids, for example, are rich in valuable minerals and water, resources that could be used for fuel, construction, and sustaining life during long space missions. By studying these objects through telescopes, we can gather the data needed to plan mining operations and resource utilization in space, making colonization efforts more feasible. A global legacy for future generations. The success of space telescopes like Hubble and Webb is a testament to the power of human collaboration and the pursuit of knowledge. They have shown that when we work together across borders, disciplines, and technologies, we can achieve incredible things. These telescopes are not just instruments. They are symbols of our collective ambition, curiosity, and drive to explore the unknown. As we look ahead, space exploration and the development of future telescopes will continue to inspire generations to come. Children who grow up learning about the discoveries made by Hubble and Webb will be the scientists, engineers, and astronauts who take humanity to the next frontier, whether that's to the farthest reaches of the solar system, to distant stars, or even to the discovery of alien life. The legacy of these telescopes is not just in the scientific knowledge they have provided, but in the way they have inspired us to think bigger, to dream larger, and to reach further. They have taught us that no goal is too lofty, no mystery too great, and no frontier too distant. In the pursuit of knowledge, we continue to push the boundaries of what's possible, and in doing so, we create a future that is as boundless as the universe itself. The power of collaborative global efforts in space exploration. One of the most remarkable aspects of space telescopes, such as Hubble and Webb, is the collaboration that spans the globe. These missions are not the work of a single nation or organization, but are the result of a concerted effort by scientists, engineers, and institutions from across the world. The importance of this international cooperation cannot be overstated. For example, the James Webb Space Telescope, JWST, is a joint venture involving NASA, the European Space Agency ESA, and the Canadian Space Agency CSA. These agencies worked together, sharing resources, technology, and expertise to create the most advanced space telescope ever built. This cooperation extends to the science community as well, with researchers from around the world contributing to the planning, execution, and analysis of data collected by these telescopes. The success of this global teamwork sets a powerful precedent for future space missions. As humanity faces increasingly complex challenges such as climate change, the search for sustainable resources, and the possibility of interplanetary colonization collaboration across national borders will be essential. Space exploration has the potential to foster peace, understanding, and cooperation among nations, as it highlights the common goals and challenges that we all share. The partnerships forged through projects like Hubble and Webb have laid the groundwork for further collaboration in the future. Whether it's through the creation of new space telescopes or joint missions to study asteroids or Mars, the spirit of international cooperation will continue to drive the success of space exploration. The role of space telescopes in understanding the origins of the universe. One of the most profound questions that humanity has asked throughout history is, how did the universe come to be? The exploration of the origins of the cosmos has captivated scientists, philosophers, and dreamers alike. Space telescopes play a crucial role in answering this question, allowing us to peer back in time to the very beginning of the universe itself. The Hubble Space Telescope has already given us stunning insights into the early universe. By observing distant galaxies, Hubble has allowed scientists to look further back in time than ever before, providing a glimpse of how galaxies formed and evolved over billions of years. Through its deep field images, Hubble has captured the light from galaxies that were formed just a few 100 million years after the Big Bang, offering a window into the universe's infancy. But the Webb Space Telescope promises to take this investigation even further. Webb's advanced infrared capabilities will allow it to study the earliest stages of galaxy formation, potentially revealing the first stars and galaxies that emerged from the primordial fog of the early universe. By capturing light from these early objects, Webb will provide new clues about how the first structures in the universe came to be, and how they evolved into the galaxies, stars, and planets we see today. In addition to studying the formation of galaxies, Webb and future telescopes will help us understand the very origins of the elements that make up everything around us. The cosmic formation of elements like hydrogen, carbon, and oxygen occurred in the first few minutes after the Big Bang, and space telescopes are helping scientists uncover the processes that led to the creation of these building blocks of life. In this sense, space telescopes are not just instruments for observing distant objects. They are time machines, allowing us to explore the past and uncover the deep mysteries of the universe's origins. Space telescopes and the search for extraterrestrial life. Another major area of interest in space exploration is the search for life beyond Earth. The discovery of even microbial life on another planet would have profound implications for our understanding of biology, the origins of life, and the potential for life elsewhere in the universe. Space telescopes, especially Webb, are on the front lines of this search. One of the most exciting aspects of Webb's mission is its ability to analyze the atmospheres of exoplanets. By studying the light that filters through the atmosphere of a distant planet, Webb can detect chemical signatures that may indicate the presence of water, oxygen, methane, and other molecules that are associated with life. In the coming years, Webb will begin surveying exoplanets in detail, looking for planets in the habitable zone, where conditions might be right for liquid water to exist, an essential ingredient for life as we know it. Beyond the search for life on exoplanets, space telescopes like Webb may help us answer broader questions about the nature of life in the universe. Are the conditions necessary for life rare, or are they common throughout the cosmos? If we find evidence of life elsewhere, what might it look like? Could life exist in forms we cannot yet imagine, based on biochemistry radically different from ours? The search for extraterrestrial life will be one of the most profound and transformative endeavors of our time, and space telescopes will be a key tool in this exploration. As we continue to probe the depths of space, the possibility that we are not alone in the universe becomes more tantalizing than ever before. The cultural and artistic impact of space telescopes. While the primary mission of space telescopes is scientific discovery, they have also had a significant cultural and artistic impact. The breathtaking images of distant galaxies, nebulae, and other cosmic phenomena that these telescopes produce have inspired awe and wonder in people around the world. These images have become not only icons of scientific achievement, but also symbols of humanity's quest to understand the universe. The iconic Pillars of Creation image captured by Hubble, for example, has been reproduced countless times in art, literature, and popular culture. The haunting beauty of the nebula, with its towering columns of gas and dust, has captured the imagination of millions. Similarly, the stunning images produced by Webb are already inspiring artists and storytellers to explore new visions of space and the future. These space images often evoke deep philosophical and spiritual reflections on the nature of existence, the meaning of life, and humanity's place in the universe. In this sense, space telescopes contribute not only to our scientific understanding, but also to our collective cultural consciousness. They remind us of the infinite beauty and mystery that exists beyond our world, encouraging us to dream and to wonder about the cosmos. Moreover, space exploration has also had a profound influence on the fields of architecture, design, and technology. The cutting-edge technologies developed for telescopes often inspire new approaches to building, manufacturing, and problem-solving here on Earth. As we continue to explore space, the creative solutions required for space missions will inevitably spill over into other areas of innovation, driving progress in ways we may not yet fully understand. Conclusion: an unstoppable drive for discovery. As we look back at the journey of space telescopes from Hubble to Webb, it's clear that humanity's drive for discovery is unstoppable. These telescopes have reshaped our understanding of the universe and our place within it. They have provided insights into the origins of galaxies, the formation of stars and planets, the potential for life on distant worlds, and the fundamental laws that govern the cosmos. But perhaps the greatest impact of space telescopes is not the answers they provide, but the questions they inspire. Each new discovery leads to new mysteries, and with each new telescope, we venture further into the unknown. Space telescopes are not just tools for observation. They are gateways to the future, to new ideas, and to a deeper understanding of the universe. As we continue to build, launch, and operate these incredible instruments, we will no doubt uncover more wonders and make even more breakthroughs. The universe is vast, and our exploration of it is only beginning. With every step we take, we draw closer to the heart of the cosmos, and in doing so, we uncover more about the very nature of existence itself. The journey of discovery continues, guided by the light of space telescopes, and it is a journey that promises to illuminate the mysteries of the universe for generations to come.